All right. Good morning, everybody. It is a pleasure today to have here Petra and Romain. They are going to give a talk in our search engine schools here at the University of Padua. Petra is a researcher at the University of Grenoble, Alpes in France, and Romain is a senior tech lead at Qwant, which is, as you know, a privacy-preserving, privacy-oriented French search engine. They will give two talks. One, the one by Petra, is about the LongEval-Retrieval Lab, the lab where you are going to participate with your homework. And while Romain will give a talk about research at Qwant and the role of a PhD student in information retrieval in a company. So, guys, thank you very much for being here and for accepting to give these talks to us today. You should, Petra, you should be able to share the screen.
Okay, I will try it out. Can you see the screen?
Yes.
Okay.
We see also the. Oh no, sorry.
No? Okay.
I thought I was looking at the chat. No, that's okay. Okay, sorry.
Okay, all right.
I switch up. Sorry.
And can you hear me? Okay.
Yes.
Okay. So thank you very much for the invitation. So I would like to first talk about like what's the continuous evaluation and how do evolving collections look like. What do we call by the evolving collection? And I will talk about this especially in the like web search environment. And I will also describe the CLEF campaign which we are organizing, and then like look at how the data look like and how to do the participation. So first, just the setup in which we are working with. So we are working with a web search engine, Qwant. So Romain will be talking about it later. And let's say that we have some users and they are asking the questions to the Qwant. Qwant has some indexed documents in which we are searching, and then you get a list of the web pages which are hopefully relevant to the queries which users issued on the output. And the problem is that the questions which are asked by the users are changing all the time. So I look at the top queries asked in France on Monday, this Monday. So it was mostly about the strikes. So there were like large strikes in Rennes. And then there was like Formula One Grand Prix on Sunday. So these were the queries which were most popular in France on Monday. But on Tuesday, it looked like completely different. So there were, I don't know, some affairs, maybe some concerts. So people were asking about like completely different thing on 2 consecutive days. And of course, this is also reflected not only in the queries, but there are also new websites reflecting these kind of events. So the newspapers are writing about pretty much the events about which people are asking. So there are like lots of newspapers are writing about the strikes, of course, and we would like to be able to provide the users also the information about this news. So this also needs to be somehow added into the index, and so you are able, or the users are able to find also the information about this kind of like new events. So both the queries and the documents are like very fastly evolving inside of the search engine, and the search engine needs to somehow deal with this. So just some example of what can be changing in search engines. I was talking about web search engines, but this is like true for all information retrieval systems. So the topics of the users in which the users are interested in are changing. the documents might be being added to the index, they might be removed from the index if they are outdated. But the content of the documents is also constantly changing. So even if you have the same website with the same URL, the content is still evolving there. So for example, if you look at the main page of Le Figaro today and tomorrow, the content will be completely different. It's the more extreme case, but you can imagine that the content of blogs is also changing constantly. And then also what the users assume to be relevant is changing. So there are some trends in what is generally interested for the public. So if you look for the news today, something about manifests in France will be relevant for you. But when you were looking for the news half a year ago, maybe something about the World Cup was relevant for you, but World Cup won't be relevant for you today. So just what is assumed to be relevant is also evolving all the time. And of course, for different users, different kind of things might be relevant. So we did some simple experiment where we look at just two things changing in the collection. So let's say that we are having the same topics, the same users, the same type of how we collect the relevance assessments, but we only be adding the documents in the collection, and we will be removing the documents from the collection. So this is experiment on the on the collection Robust. So that's very well-known information retrieval collection used in many different kind of experiments, and it mainly consists of news and news documents, and all the documents in the collection have also assigned the date in which they were created. So for example, the oldest documents are from some year 1984 up till 1991, and the newest are from the 1994. So we took 1/5 of the collection at the beginning, and we were constantly removing the oldest documents from this 1/5 and adding the newer documents to this 1/5. So here you have 1/5 of the collection, which consists only from the newest documents in the collection. So so there is nothing else changing. We are only changing the documents which are coming from the same source, and always have the same size of the document collection, but the documents in which we are working with are changing. And you can see that the fluctuation, so this is a map score, and you can see that the fluctuation in the map score also in this kind of environment in which we have reduced number of variables which are changing. The map score is changing quite a lot, so it's changing from 0.20 in some cases to 0.30 in some cases. So that's 50% increase. So one thing which this kind of evolving in the queries and documents causes is that the vocabulary with which the information retrieval system needs to be working is also evolving. So this is actually example from the Twitter data and from the classification corpus. And these are how the words are used, how the vocabulary is changing. So the common words for all the years. So this consists of the collection of the tweets published in 2014. This is a collection of the tweets which was published in 2019, and you can see the list of the common words used in during all the years is pretty small. The gray part is are the words which are unique for a single year. Then there are some words which are somehow used across several years, but not all of them. So that's the seasonal words. And there are some words which emerged in, 2016 and were then used up till 2019. The dying words were used in two years and then were not used in the years afterwards. So you can see the number of especially unique words is very large there. And this can of course cause the problems to different kind of models which are trained on one data at one time point, at one timestamp, and then tested in different timestamp. So these are again results from the text classification on the Twitter data. And the task is to find out whether a tweet is positive or negative. And you can see the drop between the time when the model was trained and the time before it and after it. And these are different neural models, so non-contextualized and contextualized. And maybe except this case of this collection, you can see quite a massive drop, especially for the non-contextualized models. And this is a text classification, but we would like to look at a similar problem in information retrieval. So that's what we are working on in the LongEval-Retrieval CLE campaign. So this is the first year of the campaign. And we are interested in questions like how the search engines behave if the collection is evolving. So if we are evolving the queries and documents in the collection, like what kind of systems will be maybe more robust against these changes, which kind of systems will be less robust. So you can assume, especially if you are doing some kind of training on your information retrieval system, it might be better performing but less robust. So what kind of like tuning is good to do, or what should be the changes in the training so your system is well performing at the same time as very robust. And also connected with this is a question, when should we update our information retrieval system? So let's say that we have trained our information retrieval system a month ago, and the question is whether is it still good now, or should we somehow update it? Should we somehow retrain it? Maybe in some way should we, in which way should we retrain it? So we are generally interested in these kind of questions. And so what we are doing is this campaign is going to work with several test collections which are somehow successive. So we created one training collection from data from June 2022, and we have then two test collections from July and September 2022, and we would like to see like the changes between July and June and September and June. So we are building three separate collections about which I will be talking a little bit later. And this is all designed to be able to reflect the changes in web across the time. And we are getting the data from Qwant to be able to work on this. There is also a second part of the campaign. So I'm talking today only about the retrieval part of the campaign, but there is the same question being solved in the classification task. So exactly the same task as I showed you of the Twitter classification. So whether the tweet is positive or negative. And they have a collection consisting of tweets spanning across the 9-year period. And they are also trying to invest how the models are robust across the time. But yeah, I will be talking today about the retrieval mainly. So how the collection was created. So the collection is coming all from the data from Qwant. And it starts with some collection of the topics. So topics is some kind of like broad areas, which are the same for all collections which we are going to work with. So we create 3 sub-collections for different months, but the topics are the same for all 3 months. Based on the topics, we find the queries which are like queries coming from the real Qwant users. So these are coming from the query logs. and they are somehow related to the topics. Then we are having the Qwant index, which is and we mine the documents from the index which were displayed for the queries which people asked. So we know what kind of documents were displayed by Qwant, and we would like to provide these documents in the collection. So based on that, we create a document corpus, and we also build the relevance estimates based on the clicks, based on the click model. So I will go in detail in each of these parts. So the first part here was creation the topics, which are the same for all sub-collections which we are building. And you can see a sample of the topics here, and it's just English translation. And we are aiming for the topics which are somehow popular, so we will be able to find enough queries for them, which are somehow general, which are also diverse, so we would like to get then queries from different areas. And this should be also somehow stable, because we are now creating the queries at each month based on this. So we built several topics which are based on the trends in from Reddit data. The queries which we collected are related to these topics. So we just use the simple method where we basically create the queries if they contain the word from the topic as a substring. So in this way, we are able to get like quite a broad range of queries. These are coming from the query logs from Qwant, and we also filter them so that we are only keeping the queries which are somehow reasonable, which were frequently asked. So we are getting rid of some noise, and we are only getting the queries for which we have some reasonable amount of clicks. So we filter out the queries which are not very frequent, so therefore they might contain some kind of errors or might be misspelled. So they should be relatively clean. And these are now extracted for each sub-collection. So topics were the same for all three collections. Now we are creating the queries which are different for each sub-collection. It still might mean that there is some overlap between the queries from the training set, let's say, and test set. All the data, because Qwant is a French search engine, all the data, queries and documents are originally in French, and we are providing the English translations for them. So this is just example how the queries look like. And we are providing the automatic translations for all of them. This is just randomly sampled queries, so you can see like what's the quality of the translation. I think for these queries it's quite reasonable. There are of course queries for which like machine translation didn't work so well. For the relevance assessments, we are building the relevance assessments based on clicks. We are not directly using the clicks because these clicks can be very noisy and biased, especially if the web page on which the user click, if the web page is on the top of the list of results, the users tend to click on it much more. So this is some kind of like positional bias. So therefore, and even though that like it doesn't have to be so relevant than the website displayed on the bottom of the page, but just users tend to click on the websites which are displayed on the top of the list more. So we are trying to avoid this kind of bias, and also there are different kind of biases against like how does the snippet look like, and we would like to avoid using like so noisy data. Therefore, we use the click models, and we try to model the behavior of the users, and And we use the assessments which are based on the click model instead of the raw clicks. But the click model is based on the user behavior which is learned from the clicks. So we have 3 degrees of relevance. One is 0 is that the document is non-relevant. 1 is the document is somehow relevant, and 2 is that the document is highly relevant to the query. And apart from this, we are also planning to run some crowdsourcing for the submissions which will be sent to the campaign. So regarding the documents, we used two approaches to gather documents for the collection. For the first one, it depends on the queries. So for the queries which were, or for the documents which were displayed for the queries, we would like to put them into the collection. So there are some documents which were corresponding to the queries which we have in the collection. But having only this kind of documents would again lead to lots of bias. So this would be very clean documents which are somehow corresponding to some queries. So therefore, we also add some random documents selected from the Qwant index to the collection, and then the full collection better corresponds to pretty much the web search retrieval problem. So we add something like 100,000 documents per topic as a randomly selected from Qwant index. All the documents are in the format which is directly indexed by Qwant, so these are downloaded and cleaned, so you don't have to do any HTML cleaning. So these are in the form of the plain text. And as I mentioned, Qwant is a French search engine, so we provide the translations for both documents and queries into English. And I think the translation, especially for the documents, looks quite reasonable. And it was the system which was the state of the art, in 2019 to 2020. So maybe you can find a little bit better performing systems nowadays, but I think this, especially the translation of the documents is reasonable. For the queries, the translation is much harder because you don't have so much context for the word. So for example, the query Airport Bordeaux is translated as airport, so you are losing some information there. But here is the translation of the French documents, and I think for the documents it looks quite reasonable mainly. So here is an example of the highly relevant document for the query Airport Bordeaux, which you can see it corresponds pretty well. Here is one example of the non-relevant document, which is about shuttles going to the airport. So I think that sounds quite reasonable to me. So I was now describing how one single collection looks like. This was the data from the training collection created in June, but we are going to provide a very similar collection for July and September, which will be used for testing. One thing to pay attention to is that we would like to also measure the differences of the performance between the test collection and the train collection. And therefore, we are keeping some held out data in the train collection, which will be used for measuring this. So train collection consists of the queries and documents, and there are 2 types of queries and assessments. And there are 2 types of the queries. One is the train queries, for which we provide assessments, and one is the held out queries, for which we are not right now providing the assessments because they will be used for measuring the difference between the performance. So there are 100 held out queries as a part of the training data. For the evaluation, we plan to use the NDCG scores for each collection to be able to measure how well is the system performing. So this is, I think, suitable especially for web search. And then we will be also measuring the drop between the performance on the test collection either July and June, or September and June. And here are just some scores with the performance on the train collection. So we are providing the data in two formats. One is the track format, which is possible to be used by information retrieval systems such as Terrier. So we didn't do any special changes. I think Terrier was adapted to work with French in this case. So for example, French stop words list was used. And then we are providing the second format, which is suitable to be used by Answer-Any. So the documents are in JSON format and queries are in TSV format. And this is directly to be able to be used by Answer-Any. And you can see the differences between the scores when we run retrieval in French and when we run retrieval in English. So English is obviously having some noise here. And then we have also tried very simple neural approach. So we took the best performing system, which was BM25 run with Terrier on French data. And we took top 100 documents and we re-ranked them by the T5 system, either using the French data or English data. And yes, this leads to some improvement. Okay, so just a few notes regarding the participation. So for the participation, you need to sign up for the track at the CLEF website. Regarding the data download, the data are available on the Lindat. So here is I think the best way how to get to this link is to look at our website, and you can find a link there. But then when you go to this web page, you need to go to the bottom. At the bottom, you have this, which is download to file. And when you are going to download the file, you will be asked to sign up. So I checked, and the University of Padua is there. So you can just be sure that you are searching in the universities in Italy. You can just find Padua there, and you can use your credential from the university to be able to sign up and download the data. If you cannot find your university there for some reason, it's also possible to create an account on Lindat and download it without the university credentials. And if you have some problems, just let us know and we'll solve it out. Regarding the requirements for submissions, we have two types of tasks. One is a short-term persistence with the data created in July, and one is the long-term persistence with the test data created in September. So you can either participate in one of these or both. The thing to pay attention to is that when you are participating, we also need to be somehow able to measure the drop between the train collection and test collection. So all the participants are also required to submit the systems, the same systems which are submitted on task A or task B. The same system needs to be also run on the held out queries, which are part of the train dataset, and submitted together. And we also ask participants to provide some kind of description, and each team can submit up to 5 systems. So by the system, I mean the single system should be submitted as a single zipped file, and the single zipped file should contain the documents like in-time results. So this is a single track run, the short-term persistence results and long-term persistence results, and the metadata description for this run. If you are only participating only in the, let's say, short-term persistence task, then you need just to provide 3 files from this. So it's just this file, and the description. by team, you will have some like we are having a team name, and if system is, for example, BM25, then your name for the submission should look like this. So if your team is UGA and system is BM25, then there is a single file like this, and that's a single track file with maximum 1,000 documents per query submitted. And the submissions will be done using Git repository. So we will create a private repository for each team, which will be done in April. But if you don't have a repository created during April, just let us know, and we'll sort it out. Yeah, and I'm talking today on behalf of all the organizers. So yeah, I would like to also thank my colleagues, and yeah, if you have any questions, so this is our website, all the information should be also there, and for the questions you can either contact me directly or you can contact us on this address. So yeah, I think that's it from me.
Sorry, Petra, something went wrong and we didn't hear the last part of your talk.
Okay, so should I maybe repeat some information from it, or
We don't hear you, Nicola. We don't hear you, Nicola. Your mic is not on.
Okay, now you will hear us.
Better, yes.
Okay. So it's a lucky morning that the alarm started, but we will make it. No, sorry, Petra, for the inconvenience. You were about the slide where you were explaining the different kinds of run package you expect with the instant run, the short-term run, the long-term run, and then the meta descriptor.
Yeah, I think if there was only information about the submissions, I think everything is also on our website. I can repeat it, or you can.
Yes, that would be helpful for the students to have a first understanding on what they are expected to do.
Okay, so it was from. Okay. And it was around this slide, or?
Yes, this one.
Okay. Yes, so each system should be submitted as a single zip file, and the file should, a zipped file should consist of 3 or 4 of these single files. So team system.wt is our in-time results run on the held out data as a track run. Team system st is our results for the short-term persistence task. LT are the results for the long-term persistent task, and then we require the participants to also provide some run description. Each file is in a track format, which is a standard for similar type of tasks. And for each query, it's possible to return maximum 1,000 documents. And if your team name is, for example, UGA, and your system name is, for example, BM25, then the file name should look like this. If you are deciding to participate only in the short-term persistence or only on the long-term persistence, then one of the files in which you are not participating in might be empty. And we will be using Git repository for doing the submissions, and each team will have a private repository created during the April. But if you don't get the information about this during the April, then contact us, please. And yeah, I was giving thanks to all my colleagues working on this with me. And yeah, you can find all the information on our website, all the link to the from where to download the collection. And if you have questions, then you can either contact me or you can contact all of us on this email.
Okay, thank you very much. So, any questions, guys, for Petra, if the network works? Any doubts about what you have to do? Is it more or less clear? No? Yes? So, Petra, a couple of things. You were mentioning that for the test set, you're going also to use a bit of crowdsourcing. One thing, if you make it available, you were discussing in the course, is to have also some of the students volunteering for doing these crowdsourcing tasks. So, do you already have plans on how you will manage these?
So I think the plan is that our colleagues in Vienna are creating their own interface for creating the for the system which will be used to do the crowdsourcing. Yes, I think we'll probably need to do some crowdsourcing also on the French side, because we are directly working with the French data. But I would also like some people from not working on the English data to do the crowdsourcing as well. And I think we'll sample some of the queries from the full test set and look at some reasonable depth and so compare the query and the document, see whether it looks to be relevant. But I don't think that I have specifically the system ready at the moment, so there is still some things which needs to be discussed and prepared.
Okay, thank you very much. There is also a question from YouTube. There is Arjen online, and he's asking, on the dataset page, it lists in total the collection contains 772 train queries with corresponding assignments. What do you mean with assignments there? Are those relevance prediction by these models?
Sorry, I couldn't hear this very well. So the question is...
I will copy the question in the chat so you can read it, if I manage to do it properly. Let me see.
So that should be assessments. It's a typo. So there are around 10,000 assessments in total for the 670 train queries, and there are 100 queries, held out queries, which will be used directly in the task. Sorry, that's a typo. It should be assessments.
Okay, thank you so much. Again, Petra, and we can now continue with the second talk for today by Romain.
All right, can you hear me?
Yes.
Yeah, thank you very much, Nicola, for the invitation and for the opportunity to talk. So I'm gonna just get my video while I share. Otherwise, my connection won't be enough, I guess. Where is it? Okay, you're gonna tell me if you see anything.
Yes, we see your slides.
Okay, that's great. So yes, when Nicolas reached out to us, he wanted to have some perspective about how it works with having a PhD and working in the industry, and working in the industry where you're not in a big research lab with Facebook, Google, or these kind of things. I'm gonna start talking a bit about what I've been doing over the past few years since I got my PhD. It's not to be narcissist, but just I think I have a career path that is quite atypical, but it makes sense in the context of my work at Qwant. So I'm going to talk a bit about my path, a bit about Qwant, what we do, and I'm going to dive into two example things that we did recently within the team that were quite research oriented, and having this knowledge, this research knowledge helped us iterate very quickly and have strong results very quickly. I plan to talk a bit about the LongEval as well, but since Petra covered it pretty well, I'm just going to skip it. So yeah, just quick bit about myself. I have a software engineering background with information retrieval during my master's. I didn't do a research master's per se, but I was very interested in information retrieval and search engines because back in 2008 and 2009, it was basically the AI, the way for us to have systems that can give you some nice information, nice response towards complicated queries. So it was quite exciting for me at the time. I did my PhD, I got my PhD in 2013 at Avignon, which is a French university, on building generative models for query topical contexts. So understanding the query, what the query is about, and modeling sometimes maybe ambiguous queries into different topics. And that's where I developed, obviously, my culture and my knowledge for information retrieval evaluation. Then I continued onto a postdoc at the University of Glasgow, where I worked with the guys behind PyTerrier, doing mostly recommendation and learning to rank. Then afterwards, I started an industry experience in Canada, working in Page Jaune, which is a search engine for businesses mostly, and working on query understanding and semantic matching. And then afterwards, I started to work full remote. So I've been working entirely remotely from home for more than 7 years now. And I've been having several academic experiences working with different universities on learning to rank, audio summarization, modeling user behavior. And before joining Qwant, I've been also a machine learning consultant working with a few of my friends. So it's just a way for me to tell us that I have quite a diverse range of skills and experience, and it's really helpful when you work in the industry, especially when you in a sort of a low budget company where you have to do many different things and act on many different products. So now I'm at Qwant. It's been 1 year and a half roughly. I'm currently co-leading the core search team, leading projects that are more applied research projects and exploratory projects, with the main goal to improve the relevance of the search engine and quality of the results. I contribute to various parts of the search engine because a live search engine is composed of many different components. So I can contribute to ranking, to web search evaluation, of course, understanding the query, understanding the documents, entity linking in the queries, and so on and so on. We have many different things where a wide range of skills can be quite helpful. So I'm going to talk a bit about Qwant in general and the core search team to give you a bit more of context. So as Nicolas stated at the beginning, Qwant is a privacy-preserving web search engine. We are a French company, so it's mostly we target mostly the French market, but we also have quite a number of English and other languages, such as Deutsch, German, in the index. So it's privacy preserving because we're not storing any user-related information, and that's real, and that's giving us some problems sometimes because it's quite a difficult task to not know anything about the searches of the users. So we cannot track any search session. We cannot track any repeated queries, any query reformulation. We don't have this information. It's a company that has been founded 10 years ago and had quite a bit of trouble for some years, and went through many changes internally. Right now, there are roughly 90 people working there and 50 in the tech team. But the tech team is the team that gathers everyone working from the front end to the infrastructure with our own servers, to the core search team that is building the actual search engine, and so on. It's serving roughly 200 million queries per month. And Qwant doesn't answer all of those queries. It answers roughly 30% of them with its own index, and the rest is forwarded to Bing. And so Bing gives the answers for the remaining of the queries. As of core search, so core search is the team, the project that is responsible for building, maintaining, and improving the entire search stack. So we have 14 permanent members that are distributed across developers, back-end developers mostly, DevOps, data scientists, and it's led by three leads. So we have two leads responsible for delivering for delivery projects, and myself responsible for discovering so projects with no real expectation of production value. And then we also have currently 4 interns and 1 manager managing the team. The entire indexing, retrieval, and ranking system is based on a huge open source project that is called Vespa, that allows to scale to large number of documents and with very high query throughput. So we have quite a decent index with roughly 5 billion documents. A few months ago, we had the double, so we had roughly 9 billion documents, and we basically removed a large number of documents based on a spam classification task. As I said before, our language scope is mainly split between French and English. We have many in-house components and tools that we have developed within Core Search. For example, we have our own web crawler, which is quite a big piece of software. It used to be Apache Natch. Now we have our own. It's written in Rust. It's highly scalable. We have our own IR evaluation tool. It's mostly a wrapper around LongEval, which is your go-to tool for evaluating retrieval systems, but it allows us to compute also custom in-house metrics. We have a tool that performs federated search. So it's basically the way for us to combine the results of various different indexes. We don't have one single index. We have one main index with containing web documents, general web documents, and then we have specific targeted indexes. And so we have a way to merge all these results together so that they make sense in the final results that we present to the users. We also have developed our own machine learning library that's basically also wrappers around well-known tools that helps us handling all sorts of data formatting, preprocessing, our own preprocessing, and training the various models that we use inside Qwant and inside the core search team. So now that I gave you a bit of context, I just wanted to give you some concrete examples of why and how it can be useful to have a research background in the industry, and especially in two concrete examples of retrieval problems that we tackled recently. First one was to learning to rank with implicit feedback. So learning to rank, if you're not familiar with it, it's basically supervised machine learning for optimizing the results that you're going to present to the users. As Petra said, she presented some results of using, for example, BM25 with re-ranking with the T5. So learning to rank would be the second step of re-ranking. And it happens after a first phase of retrieval, and then afterwards you apply some fancy models to re-rank the results. Implicit feedback is basically user clicks on documents. As Petra said, the clicks are usually heavily biased because people tend to click on top-ranked results on a search engine because they trust the first results more. And the clicks tend to be noisy as well. Sometimes people don't click on relevant results, and sometimes they also for unknown reasons. And sometimes they also click on irrelevant results for unknown reasons as well. The nice thing about noise is that you can remove them with lots of data. So taking lots of query logs, you can attenuate this noise, but you cannot remove the bias. So this problem is usually solved by training a learning to rank model with the raw clicks, but using an unbiased loss. But we didn't do this because we couldn't at the time. So our solution was, instead of debiasing the training, it was debiasing the data. So Petra talked about click models before. So yeah, these click models are basically probabilistic model of user behavior on a search page. And they allow us, by taking large amount of data, to compute the probability of attractiveness of a document given a query. And so we can use this probability as a proxy for document relevance. And that can help us generate cheaply quite a lot of training data. For improving our learning to rank, what we did is we fitted a click model with 8 months of query log. I don't have the numbers, but I think it's quite big. It's quite 200 gigabytes of compressed data. So we had to do distributed computing over Apache Spark on a large cluster. And from this click model, we sampled 600,000 queries with all the document relevance estimates. And for each of those queries, we additionally sampled negative and irrelevant documents for each query. And that gave us our training data. And then we could optimize many different models. We chose GBDTs, boosted decision trees, because they are highly interpretable and they worked quite well in our use case. We use, I don't mention it, but we use quite a large amount of features, document features, we have more than 200 features in this model. So they are mostly query-dependent features, so scores for matching the query with different parts of the documents, understanding whether the query words are close to each other in different fields of the documents and these kind of things. In the end, it showed quite a nice improvement on ranking quality for most frequent queries, about 30%, and for low frequency queries, we went to almost 100% improvement, mostly because the results were quite low for these queries. And so when I talk about improvement in ranking quality, we look at mean reciprocal rank, NDCG, and expected reciprocal rank as well. So this was one of the first example. The second one, I quite like it. It's quite recent. It's also applying some machine learning model, but not for second phase ranking. It's for maximizing the quality of the first phase retrieval. So since we rank into multiple phases, actually at Qwant we have roughly 4 phases, but I just keep the first phase and second phase. So the idea of the first phase is you want to get as many relevant documents into your top N documents as possible before taking all these sets to your learning to rank model that is going to optimize the order of the documents. And so for this first phase, we want to maximize recall, but also to be quite efficient. So this first phase is traditionally performed using BM25, which is Petra did in the results she showed you. But the problem is if we use BM25 on a big web index such as ours, you're going to get just spam. You're going to get a really huge stack of crap coming out of the index. So you need to optimize it in some way. Currently, the state-of-the-art first phase retrieval are relying on trained sparse models that actually extract the most relevant words from a document and index those words and do the same for a query and perform this kind of matching. But we couldn't do this. And we wanted to rely only on what we have currently in our index, which is the document content with very, very different fields, and also many attributes. We have attributes such as the page rank, different web document quality measures. We have estimation of the spam. We have all these different attributes that we can leverage for first phase retrieval. But the problem for learning this kind of function to optimize a recall at a large number, recall at K, for example, if we want to optimize recall at 10K documents, it can be quite challenging because you cannot build a data set where you have 10 relevant documents and then 10,000 negative examples. So we simplified our tasks, optimizing over a very smaller set of documents with a reduced sample of documents that match the query tokens. And we trained very simple linear models using 23 efficient features. So we used efficient features because the document set can be quite large, sometimes spanning over 100 million documents. And if you want to compute features over all these document sets, the function, the features must be really cheap to compute. So we have 16 query independent features that mostly act as a document quality filter. Another one we have. and based on spam classification, page rank, these kind of things, and other features based on text matching functions over the document fields. And then we built a custom long loss function that takes into account cases where the number of relevant documents is below the threshold that we optimize on. And we implemented using RAX, which is a library built on top of JAX that implements differentiable implementations of recall and precision. And that gave us quite impressive boost in results. For example, our recall at 1000 tripled. And this recall at 1000 is quite important to us because we take the 1000 documents per query to use learning to rank afterwards. So the quality of what we give to the learning to rank has tripled. And the recall at 10,000 improved as well. And so this recall at 10,000 is also important to us because that's what we keep from the first phase ranking for. So yeah, now I was going to talk about the LongEval, but I just removed the slides. Just gonna give you some final words about this. So this is just a sample of tasks where having knowledge in IR research has been very helpful and helped us get to solutions quickly and solutions that impacted the quality of our product and the quality of what we present to the users. And as you know, IR research is also deeply connected to NLP, deep learning, and machine learning in general. So going into IR research is not a niche because you need to be skilled with all these different topics and skilled with that are very valuable in the industry and that will continue to be, and not only in big research labs. And for example, I leave you with this. At CoreSearch, 3 of us have a PhD, but in data science related fields, and it helps us have some knowledge and be quite rigorous with experimentation and mentoring others and helping move the team forward into best practices. Yeah, I think that's it for me. Thank you.
So guys, any questions for Romain from an industry perspective? I mean, you are going to get graduated next year, hopefully, and then you will have to seek around to decide what you do. Any questions? Don't be shy.
Oh, you can ask me later by email. That's completely fine.
Yes, one thing is that there is often a misconception about PhD because you often think that is done for the purpose of becoming a professor or an academic, but that's not necessarily the case. Most of the works in top tech industry and can be big players or smaller players, but top tech in the sense of edge of technology we have today will require a PhD in a way or another. So this is something you may take into consideration depending on what career perspectives you are aiming at. Super silent, super shy. It must be the screening with YouTube. Okay, guys.
Question.
So you have a question.
Yeah. So thank you, Romain, for your very interesting talk. So I was curious about your learning. Is certainly impressive. I was wondering.
Guglielmo, you were chopped.
Oh, okay. So I would like to ask you about the 8 months of query logs, since Qwant is particularly leaning toward the privacy aspect. I was wondering what kind of process you did on such query logs to remove possible private information, ego surfing, and so on.
Yeah.
Thank you very much.
Yes. So this is something that dates back to quite the early days of Qwant. So the idea is just we do not track anything, but when we say we do not track anything, of course, you can, some information can leak from having queries, but we cannot link any query to any user. So for example, if you enter a query on Qwant and click on the results, then it's gonna send a line to our query log saying that someone entered this query 1 and clicked document B, for example. Then if you stay on the same results page and click on document C, then it's going to send another line to our query log saying that another user has entered another query that happened to be the same as the first one, but we cannot ensure that this is exactly the same query and has clicked on another document. So for us, if you are clicking on several documents in the search engine results page, it counts as multiple people doing several times the same query and clicking on different results. We have no way of tracking just reconstructing user sessions. It's impossible for us. For legal reasons, because we are bounded by French law, of course, because we're a French company, we need to keep some private information that are mainly related to, terrorism, pedocriminality, these kind of things. So we can identify some users for a limited amount of time, but this is, just legal stuff. But we do not use it for ranking. We do not use it for generating training data and these kind of things. We have a team that is quite committed to not cheat.
Thank you very much.
Any other questions? Any curiosity? I have one question. You were saying that you have roughly a 35%, 55% split between you and Bing. But how do you decide where to route a query and what are the factors?
Yeah, so that's a very interesting question, and we're still working on this. So actually, to be quite simple, it could be an entire topic. We answer to roughly 35% of the most frequent queries, because that helps us limit the calls to the Bing API, which we pay for. So roughly this is it, but it's not that simple because there are some queries for which we don't want to answer because we are not confident in the results, the quality of the results that we're going to show. So we have some ways to quantifying how much our results are good to show or not, and if they're not, we're gonna just call Bing. So we are using Bing for some head queries because of this.
Okay, so basically you are using some query performance prediction techniques to estimate what could be the most convenient strategy to implement.
Yeah. To put it simply, yes, exactly.
But just to give, because maybe then we will talk about query performance prediction to the students, so they know that this is a possible application of that.
Exactly. Yeah.
Okay.
And especially if we have a combination of pre-retrieval query performance and post-retrieval as well.
Okay, so
mixing the two. Yeah.
Thank you very much. Any other questions? Okay, so let's thank again both our speakers.
Thank you.
It was really a pleasure to have you here, and thank you so much for the time you devoted to our course. And we will see each other at LongEval.
Yes, thank you very much for the invitation. See you soon, and don't hesitate to reach out to us if you have any question.
Thank you. Goodbye. Have a nice day.
Bye-bye.